Hello there, it's time for another Atari ST video, and today I'm going to be tackling the mouse. Now, the mouse that came with my Atari ST has a very common problem. It doesn't click anymore, although after using it for a little bit I've identified how it's failed a bit more and I can actually get it to click. I have to go past the click point and then press really hard and it'll actually register. This makes double clicking quite difficult, but you can do it if you try hard enough. There we go. So it's possible to be used. Electrically it works fine, but mechanically the switch has failed. So today I'm going to attempt to repair this mouse by replacing the switches. And I'm going to do it by putting micro switches from a modern mouse into it. Now this is going to be a bit of a challenge because both of these switch types mount with through-hole connections, but modern mice switches mount in an inline package format and not a dual inline package format like the ones in here. But we'll see that when we open it and get to it. But that's what we're going to be doing today, and I'm really looking forward to solving this problem. Now, before we get in here and tear this thing apart, I want to give you some information about it because I was advised about some things when I mentioned that this one was bad. First off, there is an add-on available nowadays that you can get to plug into the joystick ports that will allow you to connect a modern PS2 mouse. That's going to be great if you don't have one or if you don't like this mouse, and I can totally understand anybody doing that. However, I actually kind of like this mouse. I love the weight, I love how it feels, so I'm going to try and make it work. Now, most other people who would want to continue to use this mouse like I do would probably also just want to replace the switches that are in it with the same kind, and those are available from ST-specific sellers. I'm not sure where they're getting them from because they're pretty strange. As we'll see when we get in here, mine has some really weird buttons, but the type of switch that they are a dome switch, and this is why I want to replace them. Dome switches are very bad when it comes to mechanical actuation cycles. As an example, here's a dome switch listed on DigiKey's site, which is where you can buy electronic parts like this, and it's rated for 50,000 cycles. Meanwhile, the type of switch I'm going to be pulling out of this other mouse is rated for 1 million cycles. Modern mice have to be rated for a much higher number of clicks between failures, so I would like to get the advantage of that reliability in my vintage mouse. Alright, let's really get started on this by taking the mouse apart. Now, we don't actually have to take out the ball element, so I'm going to leave that in there. But there are just 2 screws that we need to remove. And that's all that holds this thing together. And this is kind of unfortunately the kind of quality that Atari was known for at the time. We have self-tapping screws. Yay. So those are not going to do well being pulled out multiple times. But yeah, that's it. There are our failed switches. So these are just really, really big. And not going to be the easiest thing to find exact replacements for. They might be out there, but they're kind of weird. But we can see that there are pins on both sides of those switches, so these are a little bit more difficult to put new replacement parts in. For comparison, let's open up the mouse I have here, which is just some garbage HP pack-in mouse, and it's really not a disparaging remark. Trust me, you're going to see inside that this thing is, well, designed to a cost and then cost reduced more. There we are. So that is it for the mouse here. The most expensive part of this whole thing might actually be the USB cable, because the mouse itself is really this chip, which contains all the mouse logic and the sensor in one part. I mean, I'm kind of surprised it even needs passives. It's probably just for the matrixing the buttons because it's only 8 pins on there. Kind of insane. But yeah, that's the whole mouse for this thing. It's so cheap that it's just a 5mm LED there for the light. I mean, man, this guide piece, I wouldn't be surprised this is part of a package that you purchase with that sensor. It's really not a high quality thing, so I'm a little excited to get the USB cable to set aside, but yeah, we're just going to be ripping the switches out of here. All right, I'm going to finish up disassembling this, so let's go ahead and disconnect the cable going to the computer. And then it looks like perhaps 2 screws here holding in the wheel axes mechanism. And there we go with that. And now we can do an interesting test. Oh, there's the controller for the mouse, it seems. Oh, it's a Mitsumi mouse. That's kind of cool. But one test I want to do here is to take my dial calipers and measure the height of these and compare it to the height of these. And doing that, they look darn near identical, actually. I'm really not even sure. Actually, I really don't even need the dial calipers. They're pretty much identical, just holding them up like that. Yeah, so if I put the one switch on here, we can see that it's pretty much directly in line with the top of that button, or the yellow switch there. So these are pretty much the same height, but the problem I mentioned, the existing ST switches are through hole with the 4 pins on the outside. These are 3-pin through holes with them in the center. Oh, it's these bigger ones, actually. So mounting those is not going to be easy. Now, I've been thinking about how I want to do this, and ooh, I wasn't expecting there to be stuff on the bottom of the board. I was actually thinking about drilling holes through the circuit board. Here, that would be totally fine, but over here, that's going to be not possible. There's a lot going on there. Why is the IC on the bottom? Oh, because it's a single-sided board. That explains that. Well, that kind of throws a wrench in my plans. Because I really thought I was going to desolder these, drill holes in here, pop the switches in place, maybe offset them a little bit, turn them sideways, I don't know. And then run wires over to the actual contacts. But now, I don't know so well. Let me look at my choices here. Okay, here I'm doing a resistance measurement on the switch. When I first press it, we'll see that it jumps to a couple kilo ohms-ish, jumping around. If I press harder on it, we'll see it can go down to about 100 ohms. But that's really not the way that this is supposed to work. So the switch is very clearly bad and needs replaced. See if I can try and get that on here. I had to clean the stuff off of the other one. Yeah, so the right click actually works perfectly fine, maybe. It looks like the right click's fine. I have no idea what you use right click for on the ST. I don't know why that's showing up as negative either, but it seems to be working. So, yeah, the left click is definitely toast. I would like to replace both, but it would be really easy just to replace that one if I wanted to. So, I don't know. It seems a little too hacky for me, though. But it's very, very clearly bad. Oh, and the resistance on the micro switch starts out at a couple hundred kilo ohms. Press it in, and half an ohm. Doing way, way better than the ST switches are. Okay, let's try something here. So I'm going to desolder the right mouse button because that will probably been used less. And look at my options for putting that on there. I'm looking at the way the plastic case is on it, and I'm wondering if possibly it could be trimmed down to be made a little shorter, and then I could fold the legs out underneath. I don't know, but I'm going to look into that once I get it off of here. So yeah, we can see there's a couple of little ridges where there's holes for some reason, and I'm wondering if maybe those could be flattened down. It looks like the pins could easily fold. They're flat in that direction, so I folded these out. That's a little stiff. Well, it's interesting. Let me try desoldering this. Oh, that is some stinky old solder. Usually I like the smell. This is not good. There we are. So, oh, whoa, that's close. I wasn't expecting that. Okay, so these are labeled C for common, NC, and, or no, C, NO, and NC for common, normally open, and normally closed. I actually probably should have measured these at the extremes when I did my resistance test. Normally closed. Oh, normally closed. Duh, normally open is what I want. There we go. Okay, so that won't quite work if I just use the more extreme ones. Yeah, like 30 mega ohms. Wow, as far as it even registers. And nothing. Okay, so that's a real shame, because that would have been awesome just to be able to snip that one off and then just feed it in there. Oh, that would have been nice. Oh well, I'm going to keep exploring my options. Ah, well, that explains some stuff. The switch type is an Omron B3F. Okay, now that we know what it is, I can find a data sheet. They show pictures of types earlier up above, but those are all 6mm switches, and this is clearly a 12mm, so we're down here. It's a projected type, okay. We have two different kinds. There's a yellow one here. Well, it's got to be the yellow one. So it would be a B3F 4055, and it looks like it's 2.5 newtons or 260 grams to activate it. So if I do this and that to zero it out and press the switch down, yeah, we're at about 260-ish to activate it. Okay. Now, granted, that's just the bare minimum to click it in. When you're clicking, you usually overshoot. So it'd probably be about that much. Maybe 300, 400, 300, 400 I could see for a mouse click. But the B3F 4000 is supposed to be rated at 1 million operations. So that's weird that they're failing. But these are not invulnerable. I did mention how the micro switches in a modern mouse are actually supposed to be rated for extremely long periods of time. This is an extremely well-used MX518 on original. The mouse click on this will still register, but if you press too hard, it'll actually go through and lose contact. So these switches, the micro switches, do eventually fail as well, sometimes in weird ways like that one. But yeah, these are supposed to be much higher rated than DAC switches. I almost don't believe them that it's supposed to be rated that highly, because these work by bending metal inside, not like the micro switches do. These use a spring that's actually curved. This is literally a dome inside that's fatigued. It gets stretched, so that's weird. But yeah, 1 million operations. So I mean, I guess I can't fault Atari for picking a really terrible switch this time, like I did with the CX40s and the other 2600 joysticks. So they tried to find one that was rated for high life, but it just failed over time. Alright, I looked on DigiKey's website. You can't get a micro switch with a different pinout. I tried looking for normally off or momentary off switches, and they just cut off the normally closed pin rather than changing the actual pinout. So what I'm going to do here is I'm going to, actually it's this way, I'm going to put the common pin in the back here, okay, because the red... Okay, new plan. Here is the dome switch, and here's the micro switch. It's not installed. I bent all the leads, and I'm just going to sit it on top, and then I'll probably glue it in place. But now I can just run the wires off to the side. So this is probably the best non-destructive way of doing this, and yeah, it turned out there's a lot of flop in the position of the button, the switches there. There's plenty of space for extra height, so I'm not that concerned about it. Now I just need to center it, and that's going to be a lot easier. I can hot glue it in place or something like that. It won't be an issue. So yeah, now I'm going to go get some super thin wire that I can run to the different places and then attach that. Then I'll glue it in. All right, that's electrically in place, and mechanically it's all working. This is down flush. It's not over-stressing the switch. That's gonna work. That's a micro switch installed in an ST mouse. That's awesome. All right, now to do the other side, and also let's put a little hot glue down on this to secure it now that it's in place. Just to make sure it doesn't get any ideas. Oh, that is so much better with both of those. Unfortunately, I can tell the left click one is a little degraded compared to the right click one, so that melting thing I did might have made that one slightly worse. I can always replace it later now that I've got an idea of how, but it still tested electrically good, so I think it'll be fine. So I am going to go ahead and reassemble this now, which there isn't much to do. I should put the ball back, which I could do afterwards, really, but that's fine. And then plug the cable back in and put the shell back on with screws, and that's it. Okay, get this booting up here. And all right, that works. Let's... Oh, that's so much better. Oh, it's a mouse. It works. It does the mouse things. So there's no double click there. Oh, that's so much better. Wow. I could just use it. It doesn't... I'm not, like, constantly slamming on it. Oh, medium on a television is not great. Yeah, monitor's gonna have to be next. But that's it. That works. Wow. Okay, just don't melt the switch so it sounds better and feels better. It's not as snappy, but it works. So, wow. That's excellent. I still need to get a disk drive interface for more software sorted out. I actually, yeah, I really need to do that. I've heard, and I've actually heard that you can make these disks for the ST on a DOS PC. So apparently it's not weirdly formatted like Apple disks are. So it should be possible for me to do that, but I haven't looked into it yet. So I might want to try and do that because there are some single-sided disks out there, so I don't have to make the floppy interface cable yet, but I do need to do that. I have some ideas, and maybe that'll be next, because the monitor I'm going to have to order parts for, and I don't think I have to order parts for the cable, but I don't know. I'm going to look at it. For now, though, oh, this is so great. I'm really excited about this. I wish I knew what right-click did, because I can't test that on anything, but I'm happy enough with this. This is very clearly working, and it's so much better. So that is an absolute success. I hope that helps anyone else who has one of these, because these switches are terrible, and I don't want to put those back in, even with new ones. So yeah, glad to have those be gone. Micro switches are definitely what a mouse should have, so that was a very worthwhile upgrade. If you enjoyed this video, you may want to subscribe, because there will definitely be more Atari ST videos and Atari ST repairs, because I still gotta get the monitor going, and then I'm gonna make a floppy cable and then It's probably the joystick adapter still. Yeah, just keeps going on, but I'm getting closer to being able to use it. If you want to support the channel, I am on Patreon, but for now, that's it, and I'll see you next time.